Welcome. Today, we're diving into the technical world of modern fire apparatus and water delivery. We'll explore truck classifications, incident operations, and the mechanics behind centrifugal and priming pump hydraulics. Plus, we'll look closely at high-pressure hose reel technology. This is all about understanding the tools that keep firefighters effective and safe. Let's get started. Today, we're diving into apparatus tech. That means looking closely at the standard setups and capabilities of emergency vehicles. We'll focus on how these vehicles are classified, all under the guidelines set by the NFPA standards. This module gives us a solid foundation for understanding the different types of apparatus and what each one is designed to do. Let's get started with the basics of apparatus classifications. Let's take a look at the main classifications of firefighting apparatus. First, we have wildland and light attack units. These are types 3 through 7. They're built for off-road use and quick, mobile suppression, often equipped with pump and roll systems to fight fires on the move. Then there are structural capabilities, types 1 and 2, designed for tackling structural fires. These rigs need powerful pumps with high flow rates and a large set of ground ladders to handle complex building emergencies. Let's break down the key specs for a Type 1 fire engine. It needs to carry at least 1,200 feet of 2.5-inch hose, plus 500 feet of 1.5-inch attack lines. The crew size is 4 fully equipped firefighters, enough hands to handle the toughest situations. Water capacity, a minimum of 300 gallons on board. And the pump, it's rated to deliver at least 1,000 gallons per minute. These standards ensure the engine is ready for serious firefighting right out of the gate. Let's talk about the Type 2 urban and suburban pumper. This rig runs smoothly with just 3 crew members, making it efficient on personnel. It carries 300 gallons of water on board, enough to tackle many common emergencies. With a pump rate of at least 500 gallons per minute, it delivers solid firefighting power. Built for suburban neighborhoods with medium density, it strikes a balance, strong enough for structure fires, yet compact and nimble for tight streets. Versatility and maneuverability are its key strengths. Let's talk about the key features of Type 3 and 4 engines used in firefighting. These rigs carry over 500 gallons of water, which is crucial when fighting fires in remote areas. They're designed to pump water while on the move. That's the pump and roll capability. Pump rates vary. Type 3 delivers at least 150 gallons per minute, Type 4 at 50. And they're built tough, with high ground clearance and heavy-duty four-wheel drive for off-road challenges. Let's look at 3 types of light attack units designed for quick response in wildland firefighting. First, the Type 7 is extremely lightweight, with a maximum weight of 14,000 pounds. It carries just 50 gallons of water and a 10-gallon per minute pump, perfect for rapid, minimalist interventions. Next, the Type 6 steps up with a light pickup chassis, holding 150 gallons and offering great maneuverability in brush. Finally, the Type 5 is the heaviest of the 3, with a 26,000-pound chassis, a 400-gallon tank, and a 50 GPM pump for more substantial, fast-acting fire suppression. The Quint fire apparatus is a true multitasker. It combines 5 essential functions into one vehicle, making it incredibly versatile on the fireground. It carries a large water tank, at least 300 gallons, and includes a powerful, permanently mounted pump that delivers a minimum of 1,000 gallons per minute. Along with hose and ladder capabilities, it's designed to handle both engine and ladder duties seamlessly. This convergence means faster, more efficient responses when every second counts. Let's talk about mobile water supply units, the workhorses of water transport in areas without hydrants. These units, often called tenders or tankers, carry between 1 and 4,000 gallons of water. Their tactical job is to feed static portable dump tanks, using multi-directional valves that allow for fast, high-volume dumping. They're essential for supporting operations in rural or remote locations, where reliable water sources just aren't available. Let's talk about aerial and special apparatus, the heavy hitters in rescue operations. These vehicles are built for tough jobs like vehicle extrication, trench rescues, structural collapse, and high-angle technical rescues. They're also equipped for hazardous materials containment. Heavy rescue units come with rugged buckets and tactical water monitors, creating safe platforms for high-altitude work. Then we have aerial ladders, hydraulic, heavy-duty, and extending well over 75 feet. They're designed for high-elevation extraction and powerful water delivery when it counts most. Now, let's dive into apparatus technology, the tools and techniques that shape how we deploy water, manage drafting, and move tactically on the fireground. This module focuses on the practical side of firefighting operations, where every decision impacts effectiveness and safety. We'll explore how these elements come together to support firefighters in the heat of action. Understanding this helps us work smarter, faster, and more coordinated when it matters most. Let's dive into some core suppression operations that keep firefighting effective and efficient. First, frictional compensation. That's adjusting engine pressure to overcome hose friction, based on diameter and length. Then, water shuttle tactics, using mobile tenders and drop tanks to maintain supply in rural areas where hydrants are scarce. Exposure protection comes next, deploying wide fog and high-flow master streams to shield nearby commercial buildings. Finally, initial attack deployment, sending in fast attack lines for quick interior knockdown and cooling. Each tactic plays a crucial role in controlling the fire. Let's talk about drafting and how we source water from static supplies. This method uses rigid hard suction lines and strainers to pull water. There's a theoretical lift limit of just under 34 feet, but in practice, fire crews usually work within 10 to 15 feet. To get water flowing, air has to be removed from the suction lines, creating a pressure drop. Drafting is crucial when there are no hydrants nearby. It lets us tap into lakes, pools, or reservoirs. It all comes down to using atmospheric pressure to move the water. Let's talk about tactical pump and roll operations. This technique keeps water pressure steady and strong, no matter how fast the vehicle is moving. To pull this off, we rely on extra engine-driven pumps or advanced power takeoff systems. The key is that the fire pump runs completely independent of vehicle speed. This method is especially useful in brush clearing and perimeter control, where firefighters attack the fire line with handlines while the apparatus moves alongside. It's a dynamic way to suppress moving wildland fires effectively. Let's dive into the engineering behind some of the toughest liquid displacement systems out there. We're talking about apparatus tech, the kind that powers fire pumps and hydraulics. These systems need to be incredibly reliable, built to perform under pressure, and designed with precision. In this module, we'll explore the core principles that make these machines work so well, even in the most demanding situations. Let's talk about onboard fire pump designs, the heart of many firefighting vehicles. These pumps can be powered by the vehicle's transmission PTO or by independent diesel motors. They're often used in pump and roll setups, where mobility and water flow go hand in hand. We've got auxiliary and PTO pumps that are self-priming, essential for clearing air from the pump housing during drafting. Then there's the main operational pump, usually centrifugal, spinning an impeller to deliver a steady, high-volume flow under pressure. Let's talk about how centrifugal fire pumps work. They need external priming. They can't pump air, only water. Inside, a brass impeller spins fast, pulling water into its center. The impeller vanes then fling the water outward, creating pressure inside the volute housing. It's a clever way to convert kinetic energy into powerful water flow. All this happens with simple mechanical valves, allowing the pump to move huge volumes of water without taking up much space. Let's talk about positive displacement pumps. They're key when we need to switch to drafting mode at static water sources. Unlike main centrifugal pumps, which can't create a vacuum if they're filled with air, these small electric-driven rotary primers clear the air out. That lets water flow into the main pump. They're also great for tasks like injecting high-viscosity foam or purging air. These pumps move a fixed volume of water with each rotation, pushing it out mechanically. Rotary gear and vane types are common examples we rely on. Let's take a closer look at the flow capacities required by NFPA standards for fire apparatus. This slide gives us a clear comparison of the minimum gallons per minute, or GPM, that different vehicles must deliver. Understanding these flow rates is crucial because they directly impact how effectively firefighters can control and extinguish fires. It's all about making sure the equipment meets strict performance benchmarks, so safety and efficiency go hand in hand. Now, let's focus on standard agent allocation, a key part of how we organize resources efficiently. This approach ensures that each agent is assigned tasks based on clear criteria, balancing workload and expertise. By doing this, we keep operations smooth and responsive, avoiding bottlenecks. It's a straightforward system, but it makes a big difference in how well the team performs day to day. In this module, we're diving into apparatus technology, focusing on quick-attack booster systems and high-pressure water mist technologies. These tools are essential for rapid response and effective fire suppression. We'll also explore hose reels and deployment strategies, looking at how they work together to get water where it's needed fast and efficiently. Let's break down the tech that helps firefighters stay ahead in critical moments. Let's talk about booster hose reels, sometimes called quick-attack lines. These are designed primarily for smoldering rubbish and controlling wildland perimeters. They usually flow at a lower rate, between 15 and 30 gallons per minute. The tubing is built with a rigid or semi-rigid rubber jacket, so it won't collapse during use. What's key is that these reels stay under pressure all the time, ready to go instantly. That means no delays when speed is critical for perimeter control. Let's talk about high-pressure and ultra-high-pressure hose reels. These reels need heavy-duty casings to handle the intense pressure. They're designed to conserve up to 90% of water during interior fire attacks. That's a huge efficiency boost. The ultra-high-pressure systems operate above 1,000 psi, breaking water into tiny droplets. This atomization helps absorb heat quickly, leading to faster knockdown of fires. It's all about advanced thermodynamic misting, using science to fight fire smarter and faster. Let's break down the key fire hose specifications that guide how firefighters choose their equipment. We start with the booster line's small diameter, low flow, perfect for quick attacks on dumpsters or small brush fires. Next, the attack line, a bit larger, with enough flow to handle interior structural fires. Then, the tactical line, bigger still, designed for large volume attacks or backup support. Finally, the large diameter hose, or LDH supply. This one moves massive amounts of water from hydrants to engines, keeping everything flowing. Each hose has its role. We've reached the final slide in our training program. If you have any questions or need technical support, you can reach out directly to our lead instructor via the email provided. Thanks for joining us in this fire apparatus and pump operations training. We hope you found it valuable and feel more confident in your skills moving forward. Remember, support is just an email away. Before we wrap up, here are the sources for the images used throughout this presentation. They come from a variety of places, from technical diagrams to real-world photos. These visuals helped us explore the inner workings and applications of pumps and fire trucks in detail. Giving credit to these sources is important, as they provide the foundation for the clear and accurate visuals that supported our discussion today. That wraps up our presentation. Before we go, here are the sources for the images we used, giving credit where it's due. It's important to acknowledge the work and resources that support our ideas. Thanks for joining me on this journey. I hope you found it insightful and inspiring. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.
There are four main types of fire truck pumps: centrifugal pumps, high-pressure pumps, combined pressure pumps, portable pumps. First type, centrifugal pump, most common. Uses a rotating impeller to move water. Typical pressure up to 10 bar. Most common types, FBN 10 2000, FBN 10 3000, FBN 10 6000. Check below plan for main components of fire pumps. Second type, high pressure pump. Delivers water at very high pressure. Suitable for hose reels and water mist systems. Typical pressure up to 40 bar. Third type combined pump, normal plus high pressure. Combines normal pressure and high pressure stages. Can supply attack lines and hose reels simultaneously. Common on municipal fire trucks. Example, FBN 10-3002HH. Fourth type, portable fire pump. Lightweight and portable. Used in remote locations. Ideal for forest and wildland firefighting. Conclusion. Centrifugal pumps are the most common. High-pressure pumps are ideal for hose reels. Combined pumps offer maximum flexibility. Portable pumps are essential for remote operations.
Welcome to this video on industrial fire engineering. We will be covering detailed calculations for oil tank fire suppression, focusing on the volumes of foam and water required. Our calculation fundamentals follow a rigorous mathematical approach based on NFPA 11 and NFPA 15 standards, ensuring compliance and effectiveness in fire safety planning. The universal formula, $V_C equals AGDOTR CDOTT CDOTC determines the total foam concentrate needed. This involves analyzing four variables: surface area, application rate, discharge time, and proportioning rate. For fixed roof tanks with full surface fires, the high demand requires 100% surface coverage. Suppression uses fixed foam chambers or subsurface injection at a standard rate of 4.1 L per minute per square meter for 60 minutes. Let's consider an example of a 50-meter fixed roof tank. The calculations detail the steps to determine the required burning surface area, foam solution, and the total water needed, which is 468,394 liters. Floating roof tanks require rim seal protection, where the fire is localized to the annular seal area, typically less than 10% of the total surface area. However, the high intensity increases the application rate to 12.2 L per minute per square meter. For an 80-meter diameter floating roof tank, the foam concentrate needed is only 1,100 liters. This is approximately 93% less foam than what is required for a full surface fire. Exposure cooling and radiant heat mitigation are critical to prevent structural failure in adjacent tanks. Water is applied at 4.1 L per minute per square meter to the shell surfaces within a 1.5 times tank diameter distance, covering the facing side. The fire water demand curve shows that water demand is maximum during the combined foam attack and the initial phase of exposure cooling. Cooling operations may continue for several hours after foam stops. A logistical comparison highlights the huge difference in foam concentrate. A full-surface fixed-roof fire requires approximately 14,486 liters, necessitating 4 massive foam tenders, while a floating roof seal fire requires only 1,098 liters, manageable by a single rapid response vehicle. In summary, the strategic engineering process involves 3 steps: identifying the tank type and risk area, determining the solution flow rate based on NFPA density, and surcharging resources for shell cooling of all local exposures. Thank you for watching this video on fire safety engineering and infrastructure planning. Please reference the NFPA 11 standard for low, medium, and high expansion foam for further information. These are the sources used for the images in this video.
Welcome to the video on the modern fire engine arsenal. This is a comprehensive guide to the essential tools and equipment utilized by firefighting professionals in structural and technical rescue operations. We begin with drafting and water supply. Suction hoses are heavy-duty, reinforced flexible hoses used to draw water from static sources, like ponds or lakes. They use a suction strainer and a wire mesh basket to filter debris. Fire hoses are classified by their diameter and operating pressure. This includes booster reel, attack hoses, supply hoses, and high-rise packs. each serving a specific purpose, from rapid grass fires to high-rise advancement. Hose delivery and nozzles use delivery hoses to withstand high pressure. Turbo nozzles allow firefighters to control the flow rate and spray patterns. High-flow tech is engineered for rapid heat absorption through optimized water droplet sizing. Siamese collectors, which merge low-volume input lines. Wide dividers permit splitting a single supply line. Various fittings and adapters resolve physical threading differences for rapid hydrant hooks. High-pressure hydraulic tools, or jaws of life, operate at extreme pressures. They include hydraulic cutters, hydraulic spreaders for prying, and rescue rams for pushing collapsed components away from occupants. Shoring and structural stabilization involve stabilization struts and rods, which turn shifting kinetic vectors into static ground force. Chocks, blocks, and cribbing are assembled into structured towers to prevent dynamic shifting of loads. Section 3 covers ventilation and entry power. This involves manipulating atmospheric composition inside burning structures using mechanical force, high-velocity airstreams, and specialized cutting units. For air management and ventilation, positive pressure fans inject clean, high-velocity air, forcing hot gas and smoke out. Negative and hydraulic ventilation techniques draw out hot toxins or create a vacuum effect to pull smoke rapidly. Mechanical ventilation saws include rotary rescue saws for cutting through concrete and steel, ventilation chainsaws for roof structures, and forcible entry saws for rapid slicing of lock bodies and industrial door assemblies. Section 4 addresses survival, detection, and chemical control. We will take an in-depth look at critical breathing apparatus systems, multi-layer thermal protective suits, and advanced imaging technology. Power tools and ventilation include rotary and chainsaws, positive pressure ventilation fans, and foam branch pipes. These tools enable forcible entry, smoke ejection, and Class B fire suppression using specialized foam concentrates. Protective equipment includes the firefighter turnout suit, providing thermal insulation and a moisture barrier. The aluminized proximity suit is used for high-heat environments to deflect radiant heat, such as aircraft fires. Power and scene support utilize an onboard generator for a reliable power source. Electric cable reels carry electricity to the scene. Scene and hand lights illuminate the working area in zero-visibility environments. Life support and tactical site equipment are crucial for firefighter safety and efficiency. SCBA units provide clean air in toxic environments. Thermal imaging cameras locate victims and hidden hotspots. A PAS device triggers an alarm if a firefighter is motionless. The iron and hand tools are fundamental for entry and demolition. The Halligan bar is a multi-purpose tool for prying and forced entry. Fire axes are used for cutting wood, ventilation, and demolition. Additional gear includes pike poles, AED kits, and RIT bags for rescue. The image sources for this video are listed here. More image sources are listed here. Welcome to the Rescue and Firefighting Equipment Reference Guide video. This video provides technical specifications, operational applications, and safety procedures for essential rescue and firefighting equipment. First, we look at personal protective equipment, starting with wading trousers and safety boots, which are crucial for flood rescue and water operations. Next, we have firefighting gloves. These are designed to provide essential heat and hand protection during fire emergencies. Chemical protection gloves offer protection during the handling of hazardous chemicals, safeguarding the user's hands and forearms. Dynamic rescue rope is primarily used for rope rescue and climbing applications, offering strength and flexibility. The rope ladder is used for quick access and evacuation, providing a temporary means to ascend or descend. A safety harness is vital for fall protection, ensuring the user is secure during high-angle or elevated rescue operations. The hand winch is an essential tool for lifting and lowering loads precisely during rescue scenarios. The rescue triangle is used for confined space rescues, aiding in the safe hoisting or lowering of a casualty in tight spaces. The aluminium rescue tripod is an essential piece of equipment for vertical rescue operations, providing a stable anchorage point. In the category of patient and transport equipment, the rescue sheet is used for emergency casualty transport. The fire service rope is a standard piece of equipment used for general rescue operations. The folding stretcher facilitates straightforward patient transport and is easily stored when not in use. The basket stretcher is designed for rugged terrain rescues, securely holding a casualty during transport over difficult ground. Finally, the vacuum mattress is used for patient immobilization, stabilizing injuries during transport, essential for illuminating the scene during operations. The floodlight provides powerful, wide-area illumination, crucial for night operations and large rescue sites. A multi-purpose pulley is used for lifting and pulling, aiding in managing heavy loads and accessing difficult areas. The high-performance blower is indispensable for smoke ventilation, clearing out hazardous conditions during and after a fire. The Halligan tool is a multi-purpose tool primarily used for forcible entry during emergency situations. A rescue chainsaw is utilized for heavy-duty cutting through thick materials during structural or vehicle rescues. The rescue knife is used for cutting seatbelts and straps, and also for breaking vehicle windows in extrication scenarios. A reciprocating saw is effective for cutting supporting pillars during collapse or heavy structural rescue operations. The crowbar is another tool used for opening jammed doors and creating access points for rescue teams. A bolt cutter is necessary for quickly cutting padlocks, chains, and other metal restraints. The onboard generator supplies power to essential electrical rescue tools at the site of an emergency. Hydraulic rescue tools are specialized equipment used to cut and spread components of accidental vehicles for victim extrication. The breathing apparatus protects rescue personnel from thick smoke, carbon monoxide, and toxic fumes in burning structures. A rescue helmet shields the head from falling debris, such as bricks and collapsing walls, ensuring user safety. Finally, the self-inflating shelter provides immediate trauma care for injured individuals, offering a safe environment for initial medical attention. The leak sealing bag set is designed for effectively sealing pipes and tanks that are leaking hazardous materials. Moving to specialized chemical incident equipment, the gully egg is used for sealing catch pits and sewer pipes to contain spills. Pipe sealing sleeves are specifically used for sealing various pipes to control leaks and prevent environmental contamination. A hazmat pump is essential for offloading damaged tanks, transferring chemical payload from a leaking vessel to a secure container. The chemical protective suit is necessary to protect firefighters from hazardous material exposure during a chemical spill. The rescue pack system provides an independent supply of breathable air for use during salvage and decontamination processes. In the category of hand tools, the sledgehammer is used for breaking down various structural materials like drywall, masonry, and wood during remodeling or rescue. The fireman's axe is critical for smashing through locked doors, windows, and security barriers to gain entry to a burning building. A hacksaw is utilized for cutting electrical conduits to isolate power zones, particularly important during flood emergencies. The digging shovel is used for excavation, especially in challenging environments like mudslides and landslides, to clear debris. Airlifting bags set are used to lift, shift, and support extremely heavy objects in tight spaces where standard lifting equipment cannot fit. Finally, the foldable traffic cone is used to rapidly secure emergency scenes and protect responders from oncoming traffic. Thank you for watching this video. Please like the video and subscribe to my channel for more content.